Hi again, everyone. I guess you can't get rid of me today. I'm back. Very excited to tell you a little bit more about SiTration and where we are and what we're interested in. Um, yeah, as I mentioned, I think there's just such a tremendous opportunity to be able to do separations in new ways that save money, in new ways that require less chemicals or are more cost effective. And of course, as a company like SiTration, you have a lot of opportunities and a lot of different directions you can go. This is an example of that. This is oh, it's on this side. I feel like it's too loud. That's better. Um, if you just look at these four elements, copper, lithium, nickel, and cobalt, and you just look at their role in the energy transition, right, which we talked about this morning, so that's not even all of their uses, then you see that the supply, in last year's supply, $100 billion market, but in 7 years, that's expected to grow by 3.5. So the demands are going to increase, as we all know, and the opportunities are really tremendous. And so that gave us our initial focus. I'll talk about how now we have a lot of other opportunities as well. But that's how we started, was looking at these four elements and saying, well, how could we be a part of this? How could we help extract more efficiently? And as I mentioned, the traditional way to separate one little piece of pasta from another is really based on 100-year-old technology, right? So pyro and hydrometallurgical solutions have been around for a long time, and of course they've been improved incrementally, but I really think we have opportunities for very disruptive technologies to do these separations in much more cost-effective ways. And the problem with these methods, as I said, is that, okay, maybe you have ore and you're grinding it. Maybe you have old batteries and you're grinding those, right? I mean, the idea is you're still mining, and you're just mining the metals out of the batteries instead of out of the ore. But from a membranes perspective, we're kind of doing the same thing, right? And so these are, as I said, there's a lot of chemical inputs, 10 tons per ton of output, depending on the flow sheet, of course. 25 process steps, a lot of heating, and a lot of money involved. And so what we've done is to develop this new technology, this electrified membrane-based technology. And these are results for the elements that we're most interested in: copper, nickel, lithium, and cobalt to start with. And those are directly extracted from our tests. And what we can get with this approach, as I mentioned, is much more efficient recovery. So we can reduce the total chemical consumption by over 50% and operating expenses by over 70%. Now, there are sort of two main categories that SiTration is very excited to make an impact in and to form partnerships around. One is in waste to value, which we've talked about, and here we can both look at remediating harmful elements in the waste, so we can use our filtration technology to remove elements in waste that are harmful, but at the same time we can use our extraction technology to plate out and take out valuable metals that are in there. So we can both remediate and recover and valorize waste. The other area that we're very interested in is in making hydromet more sustainable. Now, this is actually a very interesting and exciting area for us because, on the one hand, we believe that our technology could effectively replace solvent exchange and electrowinning. It's basically, if you want to think about it, it becomes something like electrowinning without the solvent exchange, right? It's just essentially like that. But on the other hand, we're also well aware that if you want to make an impact, you don't want to necessarily have to replace very expensive CapEx equipment that's already there. So the other question is, how can you improve it? And one of the things that we're seeing is that there are a lot of ways that we can actually add value to existing solvent exchange electrowinning plants. For example, in the solvent exchange process, once you're done, you might be making a much purer feed of copper but you've still got elements in there that are essentially contaminants that may lead to things like problems with viscosity or other problems down the process sheet that you'd like to improve and you can't, but if you could remove those contaminants, you would improve them. On the other hand, in current solvent exchange electrowinning processes, you're leaving behind often a lot of valuable materials. And that's another way in which we could add value to these existing process sheets, right, process flow sheets, and by extracting things that aren't removed now because they'd be too difficult to remove, but we could come in and take out things like gold or silver or cobalt or other elements that are there in small amounts that we can extract profitably using our approach, but you wouldn't be able to do it profitably because there's not enough of it using traditional approaches. And that gets to something that's really important. And I mentioned this before, but I want to mention it again. These incumbent existing technologies are not very flexible. So you invest hundreds of millions of dollars into these very large CapEx-intensive systems, and then something changes. Maybe you discover, maybe the ore grade changes, obviously it is, but maybe you also discover that there's other value that you could get out of it, but you're not going to be able to use the same plant for that. So there's not a lot of flexibility. What's really nice about a membrane-based system like SiTration's and what we're able to show is that it's completely flexible. We don't need to change the membrane to change what we're extracting, right? And we've demonstrated now that we can extract a number of these elements, even in very trace amounts. So in the tens of parts per million, we can extract in ways that our modeling tells us will be very profitable. So that's this is an example of the copper. This is out of some acid mine drainage streams that we have gotten samples of, and this is just showing one example of our current sort of tests where we can show that in a fairly short order of time we can extract 99.9% pure copper. So we're going towards 4 nines. We're at 3 nines now. In terms of purity, we can get more than 99% of the copper out, so the yield is very high. And we can do this at less than roughly 2.5 kilowatt hours per kilogram. So we're very competitive in terms of energy consumption. It's a fully electrified process. There's no chemical additions. There's no solvent exchange needed. It can work at all different degrees of concentrations. And here's an example also, because some you say, well, how do you get it off? Well, it turns out we have a lot of room to play in that side as well. So here's right after the process. I showed you it in a beaker. Here it is on one of our membranes. If it works, let's see if it. Here's just pulling it out. Maybe there it is. We're just lifting the electrode out here, the membrane out, and then you see the copper sheet just sliding off. There's the copper sheet there, kind of sliding off, and that's actually something that we can tune in terms of how we want to actually take off the extracted metals. So that's another one of those, there's a lot of there's a lot of flexibility in how we do that, which is really nice. So this is where we are, and I think again, we can save 85% of the costs compared to traditional technologies. We can, sometimes you think about, well, this new process I'm trying, right? Maybe it's bioleaching, maybe it's something else that you're trying. It's not quite cost competitive. Well, maybe we can make it cost competitive by getting some value added from some of the other minerals that you're leaving behind. So that's another example of ways we can add value to existing process flows, including ones that are being tried out experimentally, right? So this bumps up your potential revenue. And again, it's a fully electrified process, which has a lot of, I think, important values. So yeah, I'll end with just kind of telling you where we are. I think, working here in Chile, I think would be really exciting for us because of the role Chile has on the global stage in terms of copper, but also because of some of these other trace elements that are in these feeds that you're not recovering now that we think we can help you recover profitably. And I'll just say one more thing in the last 30 seconds. This is the size. I think I have a booth out there, so I'll have these over there. You can hold them. This is where we were in my research lab. This is the scale of a research membrane, right? this is the scale of a startup membrane. We're actually at about twice this. And as I showed you, we can make modules, and we've made modules of these. But the next step is to go to a pilot system. That's what we need to do, and we want to do it fast, and we're ready to do it. And so we're really interested in talking to companies that might be interested in partnering with us in identifying which part of this problem would be most exciting, where we can create the most value together, and then getting on site and showing you how this could work with a pilot system. So that's where we are, and I'd be happy to talk to you all more after this. Thank you.